annuity. An annuity is a series of payments made at equal intervals of time. Have you seen this sentence before? A series of payments made at equal intervals of time. Have we done this before? Yes?
Yes.
In what?
Yes.
Which concept?
Period.
Compound.
Compound, okay. What else? In which concept did we learn how to pay a series of payments at equal intervals of time?
Sinking fund.
Yeah, sinking fund.
Amortization.
Sinking fund. This is exactly like the sinking fund, okay? For most of us, we aren't able to put a large sum of money in the bank today, okay? So instead, we save for the future by depositing a small amount of money from our paycheck into the bank. This idea is called a savings annuity, okay? So annuity means that we are putting in a series of payments at equal intervals of time into an account, okay? There are many practical examples of financial transactions involving annuities, such as a retiree purchasing an annuity from an insurance company upon his retirement. That means sometimes you put in, when you buy an insurance, you pay premiums monthly. At the end of it, you get some money. Okay, that is one example of an annuity. A life insurance policy being purchased with monthly premiums. This is also an example of annuity. Okay, and the last one is a bond holder, somebody who has a bond, receiving an annuity in the form of semi-annual coupon payments. Okay, so these are all examples of annuity. Sometimes you have a shop or a house and you are collecting rental for that shop or a house, okay? Somebody's renting your, say your house, somebody's renting your house and they're paying you rental. They're putting this rental into an account which you are not touching at all. So this every month the same amount is going into the account. So at the end of a few years, you have a lot of money there, okay? That is also an example of an annuity. Okay. Okay. So let's look at types of annuities. Okay. So there are many types of annuities.
Madam.
Yeah.
What is the purpose of annuity?
What is the
Purpose.
purpose of annuity? Okay. Like okay, say I want some money at the end. It's something, the same purpose is quite similar to the sinking fund purpose, okay? So I want some money in say I'm going to retire in 10 years, 5 years time, let's say. So, okay, for government servants, we have a pension. But for non-government servants, they don't have pension, okay? So that means when they retire, they don't get a pay. So they want to make sure that they get something like a pay after they retire. So they put in some money every month now, and they don't touch it. So they just allow it to collect interest. So after maybe 20 years, the bank will pay them monthly money. So that means they get some income monthly. So the purpose is to get some income at a later date. Okay?
Okay.
Or if you want to save for something big and you don't have enough money now, so you put monthly, same purpose as the sinking fund. You put monthly and then at a later date, you get some amount of money. Okay, so that's an annuity. Yeah. So let's look at types of annuity. Okay, there are many types of annuity. Okay, so if we classify them according to the length of conversion period relative to the payment period. Okay, there are two types of annuities here: simple annuity or general annuity. Okay, simple annuity is when the interest compounding period is the same as the payment period. So if you're compounding the interest for 12 months, your payment period is also 12 months. For example, a car loan, which interest is compounded monthly and payments are made monthly. General annuity, when the interest compounding period does not equal the payment period. Maybe your interest is compounded semi-annually, but the payment is monthly. Okay. So if the payment period and the interest period is the same, then it's called simple annuity. Okay. If the payment period and the interest period is not the same, then it's called general annuity. Okay. This is not very, you don't have to memorize all these things. Okay. You just want to, just to know on the surface level. Okay. Okay. Date of payment. Okay. If for ordinary annuities, if you make the payment at the end of each payment period, supposing you want to do monthly payments into an account, if you make the payment at the end of each month, then it is called ordinary annuity. But if you make the payment at the beginning of each month, then it's called annuity due. There is a difference, okay? See, if you make the payment every month at the end, say end of January, end of February, end of March, then that account is called ordinary annuity, okay, that plan. But if you pay the money beginning of January, beginning of February, beginning of March, then it's called annuity due, okay? Can you understand this? These two is important, okay? These two you need to know. Because when you pay in the beginning and you pay at the end of the month, the interest calculate the terms is different already, okay? And then when in terms of payment schedule, okay, if payment is delayed for a period of time, that means when you start making your monthly, say monthly, when you start making your monthly payments, you don't get you don't get your income immediately. You get it after a certain amount of time. Okay, so that is called deferred annuity. Perpetuity is an annuity for which payments continue forever. Okay, you see, annuities there are two types. One, you can pay the payment monthly or yearly, but you make periodic payments. The other type is you make one lump sum of payment. Okay, you make one lump sum of payment, leave it in your account. After some time, then you get an income regularly, maybe every month or every quarter or every year, that kind of things. Okay, so if you make one lump sum payment and you don't get the money immediately, or if you don't get the money immediately, then it is called a deferred annuity. Okay, if you get the money immediately, it is an immediate annuity. Okay, and the last one is beginning date and end date. Annuity certain is an annuity with a fixed term. Both the beginning date and end date are known. Okay, for example, you know exactly how many installments, you know when you're starting, you know when you're ending, then it's annuity certain. Okay? Contingent annuity, the beginning and ending date is unknown. You don't know when it's going to end. That is called contingent annuity. Okay, so from all this, what you really have to know here is ordinary annuity. Okay, you need to know what is ordinary annuity, what is annuity due, annuity certain, annuity deferred. Okay, can you understand all these things?
Not really.
Okay, again, one more time. Just want to say it one more time, okay? Ordinary annuity and annuity due, we always compare these two together. When you make the payment at the end of every term, at the end of every period, whether it's monthly or yearly, it is ordinary annuity. If you make the payment at the beginning of the period, it is annuity due. You can understand that, right? Okay. Deferred annuity means after you make the payment, if say your payment is monthly, after you make the first payment, you start getting some money back the very next month. That is immediate annuity. But after making the payment, say you're making the payment monthly, you don't get the monthly, you don't get your payment or the income the very next month. You get it maybe after 5 years, after 10 years. That is deferred annuity. They defer it, they hold it, okay? They postpone it. That is deferred annuity. Annuity certain is Annuity with a fixed term. You know the beginning date, you know the ending date of the plan, and you know exactly how many months or how many years it is. That's annuity certain. So you can have an ordinary annuity certain. You can call a plan like this. Ordinary annuity certain. That means you are paying money, say monthly, at the end of every month. You know the starting date, you know the ending date, you know how many months it is. Okay, so this is one type of ordinary annuity certain. It could be something else, annuity due certain. Okay, it could be a few of these can be mixed together. Okay. Okay, I think before we go on, I just want to tell you one thing. Let me explain to you your exam first, so you know how much to study and what to study. Okay, you have 5 topics, right? In this course, you have 5 topics. Your quiz 1 was on which topic? Topic 1 and 2, right? Quiz 1.
Yeah.
Topic 3 is your quiz.
True.
Topic 3 is your quiz 2. Okay, and your exam is OBT exam, open book exam, open book, OBT exam. Okay, online based take home test, whatever. Okay, so this is your exam. Your exam only has 3 questions, 3 essay questions only. Okay, it's much easier than last semester. 3 essay. Topic 1, no questions. So topic 1, no questions at all for your exam, which means quiz 1 is already finished and topic 1, no questions. So you don't have to study topic 1 anymore. Correct? Topic 2 and 3, there'll be 1 question here. This is question 1. Wajib, compulsory question. You must answer this question. Topic 4, we have 1 question. This is section A. Okay, 1 question only must answer. And then we have section B. Question 1 and question 2. Choose 1. So you only have 2 essay questions. Okay. So if you look at this format, you only need to answer essay questions. So you study according to that. Okay? You understand what I'm telling you?
Yes, madam.
Okay. So the exam is actually quite easy. Only 2 essay questions, that's all. Okay? So you can either focus and study if you want to, or you study all. But topic 1, no need to study anymore. Okay. Okay, so we have finished with the types of annuity. So now we're going to look at the differences between annuity and compound interest. Anybody can tell me what is the difference between annuity and compound interest? Are they the same? Okay, let's look at it. Difference between annuity and compound interest. Annuities assume that you put money in the account on a regular schedule, okay? Regular schedule, either every month, every year, every quarter, every semi-annually or something like that, okay? And then you let the money sit there earning interest. You let the money sit in the account earning interest. But compound interest assumes that you put the money in the account once and let it sit there earning interest. So annuities, you put in the money regularly, regular schedule, either every month or every year. Compound interest, one time. Once you put and then you leave the money there. Okay? Annuities assume that you put money in the account. Sorry, yeah. Okay. So compound interest assumes that you put money in the account once and let it sit there earning interest. So compound interest is one-time deposit. Annuity is many deposits. Okay, but annuity, the interest is also calculated the way compound interest is calculated. Okay, this is the main difference between compound interest and annuity. Okay. Okay, so we're going to start with ordinary annuity. Ordinary annuity, also known as immediate annuity. Okay, ordinary annuity certain. Okay, this is what we're going to do. Immediate or ordinary annuity certain. Okay, they are both the same thing. Immediate annuity or ordinary annuity, same thing. Okay. In this annuity, ordinary annuity, payments are made at the end of each period. Okay, and you know how many months exactly you are going to make the payments. Okay, and you know how many months is the interest calculated for. Okay, for example, if at the end of each month a deposit of 600 is made into an account that pays 9% compound interest, okay, compounded monthly, what will the final amount be after 5 years? Okay, so for how many years will you deposit this money?
5 years.
Okay, how many deposits altogether?
60.
Yes, very good. 60 deposit. Huh? So the first payment will be at the end of the month, correct?
Yes.
So how long will the first payment be in your account? The first payment is at the end of the first month. So how long will the first payment be in the account? Okay, let's take a smaller example, simpler problem. Say 5 months. So you want to put money into an account for 5 months, okay? 1, 2, 3, 4, 5. Okay. You make the payment at the end of the first month. How long will the money be in this account?
4.
Yes, 4 months, right? 1, 2, 3, 4. The money will be in this account for 4 months. Now you are making a payment for 5 years. Okay, so this is 1 month, 2 months, 3 months, 4 months, 58, 59, 60. 60 months you're going to make this payment. You are going to make the payment at the end of the first month. Your first payment is at the end of the first month. So how many months will this payment stay in this account?
50.
How many?
60 minus 1.
59 months?
Yes.
Yes, so the first payment will be in the account for 59 months. If the first payment is in the account for 59 months, what is the future value of this first payment? How much is your first payment?
600.
Yes, so you make a deposit here for 600. First payment you put into this account. This money will stay in this account for 59 months. How much is the future value of this money? What formula are we using here?
Thinking fund
Compound interest formula, right?
or compound
Future
interest?
value. Because it's collecting compound interest, right? This money, 600, you leave it for 59 months inside this account at 9% compounded monthly. So it's compound interest formula, right? So how much is this?
600.
600 into 1 plus your I is
0.09.
over
12.
to the power of
59.
59. Yes. So this first deposit will give you collect this much of money. Okay, this is the future value of it. What about the second deposit? How much will it collect? 600. 1 plus 0.09 over 12 to the power of
58.
58. Can everybody understand that? So that means if I take the smaller example here, so if you put a second payment here, this second payment will sit in the account for 3 months. Third payment will sit in the account for 2 months. Fourth payment will sit in the account for 1 month. 5 payment. After you put in the fifth payment, you're taking out the money. So it doesn't collect interest, the fifth payment. Okay. Same like that. Okay. So here S3 is the third payment will be 600 into 1 plus 0.09 over 12 to the power of 57. What about S59? S59 will be 600 into 1 plus 0.09 over 12 to the power of
1.
1. Yes, very good. So what about S60? S60 is
Power of 0.
0.
0. Are you putting in any money on the 60th month?
Oh
Are you
no.
putting in money?
No.
Are you going to deposit? How many years are you depositing here? 60 months, right? So the 60th month, you must put in some money, right? You must put in 600, but you will put in here, but you don't have interest because
Oh.
it doesn't remain in your account, because at the 60th month, you're going to take out everything. So the 60th month, you only have 600 ringgit. Okay? So what is the total value of all this, of all the money now, from your first month until the last month? How much have you collected altogether? So the total in 5 years, is 600. 1 plus 0.09 over 12 to the power of 59 plus 600, 0.09 over 12 to the power of 58 plus 600, 1 plus 0.09 over 12 to the power of 57 plus until 600, 1 plus 0.09 over 12 to the power of 1 plus 600, correct? This is the total. Or we can write it the reverse, okay? 600 plus 600 into 1 plus 0.09 over 12 to the power of 1 plus until this is 600, 1 plus 0.09 over 12, 57. Correct? Is that correct? So this is the total amount of money. What is this? What pattern do you see here? Do you recognize this equation? Do you recognize this equation? What kind of equation is this? You have done this before, right?
Yes.
What is it? It's what kind of a series?
Amortization.
No, you look at it first.
Geometric.
It's a series. It's a series, right?
Arithmetic.
Is it an arithmetic series or is it a geometric series? Which is it?
Geometry.
Geometric.
Yeah, it's a geometric series, okay? So if you look at it carefully, it's a geometric series. And what is your A here? How much is your A? First term, A is first term. First term is 600,
600.
correct? First term is 600. What is your R? R is
0.
R first term over the second divided by the second term divided by the first term. What is R? What is the difference between first term and second term?
1 plus 0.
Yes, this is your R. Second term divide by the first term, you get 1 plus 0.09 over 12. What is your N here? N is
60. 60.
yes, N is 60, yeah? N is 60, okay? Okay. So we are using the formula as if you want to find the total for a geometric series, what formula are we going to use? What formula? What's the formula for geometric series for sum of series?
A times r minus 1 divide r minus 1.
What is the inside the bracket? It says what? Is it 1 minus Rn or Rn minus 1?
R
R
power
power n
n
minus 1
plus
Why?
R is
because r is greater than 1.
We have two formulas, right? We have A, Rn minus 1 over R minus 1, or we have A, 1 minus Rn over 1 minus R. So which formula do we use? A or B?
A, madam.
Why A?
Because the R has a value bigger,
Yes,
larger than 1.
correct. R has a value of larger than 1. Modulus R is greater than 1. Therefore, we use this formula for the sum of terms, okay? So if we put our values inside here, we have 600 into our R is 1 plus 0.09 over 12 to the power of, sorry, Rn, okay, to the power of 60 minus 1, okay, over R is 1 plus 0.09 over 12 minus 1, correct? This is also equals to 600 into 1 plus 0.09 over 12 to the power of 60 minus 1 over 1 and 1 here goes off. So this is 0.09 over 12, correct? Okay, so you will get 45254.48. Okay, this is the total of the series earlier. Okay, so when payments are made at the end of each period rather than at the beginning, we call this ordinary annuity. Okay, so what we have calculated is the future value of an ordinary annuity. Okay, so from this example, okay, we can come up with a formula for the future value of an ordinary annuity. Okay, we can come up with this formula here. Okay, so if a payment of R ringgit is the installment, is made into an account M times. n times a year, okay, at an interest of I. The final amount as a after t years is, so we're going to, this is our formula, okay? So our first, the 600 is our 600 here is our monthly payment. So this is the R, okay? So now this will be 1 plus 0.09 over 12 is our K over M, or it is our interest, okay? This one here is our N, okay? So from here, we know that the formula is, okay, it is R, S is equals to R, 1 plus I to the, here typing N periods, we write to an account for N periods, okay? Okay. Over I, okay? So that is our formula, okay? Do you recognize this formula? Is this the same formula that you used for the sinking fund?
Madam, we forgot
What is that? What is that?
I at the bottom.
I is what?
What's the denominator for this formula? I thought it was like the
It's the same, right?
sum.
These two. This is I, isn't it? This one is I, isn't it? This is I, isn't
Oh,
it? So it is
okay,
R.
yeah.
From here, we have, what is this? 600 is R into 1 plus I to the power N minus 1 over I. Okay. So either they give you I or they give you the K over M. They tell you the M. Okay. But it is still
Okay,
I there. Okay.
okay,
So this is the formula. From this, we have derived the formula. Okay. So this formula was derived using geometric progression. So you know that using this formula, you will get the sum, the total value of all the compounded values. Okay, this is the formula. And if you remember, this is the same formula that you used for your sinking fund. Okay, the accumulated value for the sinking fund, because the sinking fund is an example of ordinary annuity. The sinking fund is actually an ordinary annuity. Okay, so that's why the formula is exactly the same. Okay, so this is what we use to calculate the accumulated value for an ordinary annuity. Okay, so far okay. So I just wanted to show you how you derive this formula. This formula just didn't drop from the sky, okay? So we derived it from the geometric series just now, okay? From this geometric series here, okay? From this geometric series, we added this together, and from here, we got the formula. It is the same thing, okay? So we have actually used the sum of the geometric series, okay? This formula is directly from the sum of a geometric series, okay? Okay, so now we are going to do some examples. Okay, the future value of an ordinary annuity, okay? Questions regarding annuity. You see, annuity, it is related to compound interest, okay? So questions regarding annuity can consist of finding the future value of an annuity or finding the present value of an annuity, okay? So today we're only going to look at the future value of an annuity, okay? Present value is a different formula, okay? Okay, Maria deposits 400 ringgit into an account at the end of each quarter of a year. The account pays interest at 7%. What is the accumulated value after 4 years? When you look at the question, How do you know whether this question is compound interest or annuity? How do you know? Because the compound interest is also similar, right? How do you know that this question is using the annuity formula and not compound interest formula?
The keyword said at the end of each quarter.
Yes. So she's putting in 400 every 3 months. Every 3 months she's putting it 400. But if the question says Maria deposits 400 ringgit into an account and then the account pays interest, then it is compound interest formula. You only put in once. This one she's putting in many times. So it is an annuity question. Okay. Okay. So from here, what do we know? What is our R value? R is the monthly rental. Rent, we call it rent or the monthly payment. Monthly payment is 400. Okay. I is 7%.
7%.
Divide
Compounded.
by 4.
So it's 7 over 4. So this actually is 0.07 over 4. And 4 times a year, how many years?
4 years.
4 years. So N is
48.
16, is it?
Yes, 16.
16, huh? Okay. So now that we know this, we're going to put it into our formula. R is 400. 1 plus I is 0.07 over 4 to the power of 16 minus 1 over 0.07 divided by 4. Okay, can you calculate that? So how much is your S? S is your accumulated value. Huh? Some books will say it's A. A is also okay. So S is nobody got a calculator tonight? Okay, so the accumulated value is am I correct? 7,310 ringgit and 67 cents. Okay, so this is the future value that she gets after 4 years. Okay, so this is very similar to the sinking fund method, because the sinking fund is an ordinary annuity. Okay, so later we will do different types of annuity. Okay, so she deposits 400 ringgit every 3 months for 4 years, and this is how much she gets. This is the future value. Okay.
Madam,
Yeah.
the answer I calculated is 7,312.76.
7,312.12,
67.
not 10, not only difference is here. Yes, is that correct? Anyone else?
Yes, I got that.
You also got the same thing?
Yeah, it's 12.
Okay, so I believe you lah. So 7,312.67, Okay, good. Thank you. Okay, let's do one more example, okay? Okay, calculate the future value of an annuity of 200 ringgit per month for 5 years at 4% interest compounded monthly. Okay, so let's write down our information first. So R is equals to 200 ringgit. I is 0.04 over compounded monthly over 12. What else do we know? N is
12 times 5,
how much is that?
60.
60, yeah, N is 60, okay. N is 60, yeah. So if your question tells you at 4% interest only, they don't tell you compounded monthly. Sometimes it's like that, huh? If they don't tell you it's compounded monthly, then you look at the payment. How is the payment done? If the payment is done per month, then you assume that your interest is also per month. If the payment is done quarterly, then your interest is also quarterly. Okay. Sometimes they don't give you this. Okay. So you must assume that. So N is 60. Okay. So now we can put it into our formula. Okay. So our R is 200. 1 plus I is 0.04 over 12 to the power of 60 minus 1 over 0.04 over 12. So what do we get? Anyone?
13,259.
13,259.8.
Uh, 80.
80. Okay, correct. Huh?
Yeah.
So this is 13,259 ringgit and 80 cents. So this is the future value. Okay. So we do be a little bit later. Okay. So if you know this is the future value, so how much of interest did this account earn? How much of interest did this account earn? Anyone? Anyone can tell me the answer? Just tell me how you get it. So you put in 200 every month for 5 years. At the end of 5 years, you get 13,259 ringgit and 80 cents. How much is the interest that you earned?
Future value minus present value,
What is the present value?
200 times 60.
Yes. So the interest, yes, is correct. Interest, but we don't call it the present value, okay? So that is not actually the present value, but your calculation is correct, okay? So your interest will be your sum or your S minus n times 200, correct? N times, which is actually your R, n times R. So this is RM1325980 minus n is 60 times R is 200 ringgit. So this is so how much is this? 1,259 ringgit and 80 cents. This is the interest that you have earned. So you have to understand this because interest is the money at the end minus how much you have put in. How much you have put in is 200 times 60 for 60 months, you have paid 200, which means you have paid, up to now, you have paid 200 times 60, that is 12,000 ringgit. You have already paid 12,000, but you have earned 13,259 ringgit 80 cents. So the difference is the interest. Okay. Okay, part B. Yeah? Determine the future value after 61 months. Okay. After 60 months, you got 13,259 ringgit and 80 cents. Now, determine the future value after 61 months. How much will that be? It will be after 60 months, you got this right.
Yes.
13,259 plus 80. After the last month's payment will be 61 is the last month. The last month, how much did you put? 200. So, but you have interest on this, okay? So it is like this, huh? This is the formula, okay? Balance. Oh. New balance is equals to 1 plus I times the old balance, previous balance, times the previous balance plus R, okay? So this is the formula that we use, okay? So the new balance will be 1 plus 0.04 over 12 times the previous balance is 13,259 ringgit and 80 cents plus our R is 200. So this is the new balance. Okay, so this is the new formula that you need to know. Okay, so that is all for today, ordinary annuity. Okay, so we have learned how to calculate the future value of an ordinary annuity. Next, we will look at how to calculate the previous value of an ordinary annuity, and we also will look at annuity due.